Hello students, now we solve question number 32 from the question series of IIT JAM 2024 mathematics question paper. So this question is given from real analysis and the question is in section B. So here one or more options are true and here 4 series of real numbers are given. Let us check which series are convergent. In option A, the series is n equal to 1 to infinity n log of 1 plus 1 by n cube is convergent. Option B, summation n equal to 1 to infinity 1 minus cos of 1 by n whole into log n is convergent. Option C, n equal to 1 to infinity n square log of 1 plus 1 by n cube is convergent. And option D, summation n equal to 1 to infinity 1 minus log of 1 minus cos of 1 by root n into log n is convergent. So here for option A and C we will apply the limit form of comparison test. So for option A, here the nth term an is equal to n log 1 plus n cube. Let us take bn is equal to 1 by n square. So an by bn is equal to n log of 1 plus 1 by n cube by 1 by n square is equal to log of 1 plus 1 by n cube by 1 by this n and n square 1 by n cube. So let 1 by n cube is equal to t. Since n goes to infinity, then t goes to 0. So now limit n tends to infinity an by bn is equal to limit n goes to infinity log of 1 plus 1 by n cube by 1 by n cube is equal to limit t tends to 0 log 1 plus t by t. It is 0 log 1 0 and t is 0 0. So it is 0 by 0 form is equal to limit t tends to 0 derivative of log 1 plus t by derivative of t. So derivative of log 1 by t means 1 by t into 1 by derivative of t is 1 with respect to t. So if we put t equal to 0, then we get the value of limit is 1, which is a non-zero real number. So by limit form of comparison test, the series an and the series bn are converge and diverge together. So by comparison test, by limit form of comparison test, limit form of comparison test, since summation bn is 1 by n square, since bn 1 by n square is convergent, the series bn is convergent because summation 1 by n square is convergent. So summation an also convergent. So since summation Bn is equal to summation 1 by n square is convergent, therefore summation An is equal to summation n equal to 1 to infinity n log of 1 plus 1 by n cube is convergent. Therefore option A is true. Option A is true. So for option C, here also we apply the limit form of comparison test. Here An is equal to n square log 1 plus 1 by n cube, and let us take Bn is equal to 1 by n. So An by Bn is equal to n square log of 1 plus 1 by n cube by n 1 by n is equal to log of 1 plus 1 by n cube by this n square and this n, that is 1 by n cube. So it is this log of 1 plus 1 by n cube by 1 by n cube. Here log 1 plus 1 by n cube by 1 by n cube. So limit n goes to infinity, An by Bn is equal to 1, which is a non-zero real number. So limit form of comparison test, the series An and Bn converge and diverge together. Since Bn is equal to summation 1 by n is a divergent series, therefore summation An is equal to summation n equal to 1 to infinity n square log 1 plus 1 by n cube is divergent. Therefore option C is false. Here for option, now let us check option C and option D. So in option C, option B and option D. Option B, An is equal to 1 minus cos 1 by n into log n. So here 1 minus cos 2 into 1 by 2n into log n. 1 minus cos 2a, we know from trigonometry, 1 minus cos 2a, 1 minus cos 2a is equal to is equal to 2 sin square a. So here 2 sin square 1 by 2n into log n. So this less or equal to 2 into 1 by 4n square into log n, because we know sin x lesser equal to x for all x greater equal to 0. Therefore sin square x lesser equal to x square, x greater equal to 0. So here lesser equal to 1 by 2 into log n by n square. Let us take this series is Vn. So here an lesser equal to k into log n by n square Vn. K here k is equal to 1 by 2. So by comparison test, if this series is convergent, then the series an must be convergent by comparison test. So let us check this series is convergent. Here let Bn is equal to log n by n square. So from integral test we have to show the series Bn is convergent, because from integral test we know that if integration 2 to infinity f of x, because here log if n equal to 1 then this is 0, so we take from 2 to infinity. If integration 2 to infinity f of x is convergent, then summation an is convergent. So 2 to infinity log x by x square dx has finite value, because from integral by parts we can see this integral is convergent and this integral has a finite value. We are all know the integration. So the series log n by n square is convergent, has finite value. Therefore log n by n square is convergent. Therefore since summation log n by n square is convergent, therefore by comparison test summation an is convergent. Therefore option B is true. And option C, for option C, before to check option C, now we integral 2 to infinity f of x dx, that is integration 2 to infinity log x by x square dx has finite value. Now we prove the integration has finite value. Let log x is equal to t. So 1 by x dx is equal to dt. So So from here 2 to infinity log x by x square dx is equal to integration log x equal to t 1 by x into 1 by x dx means dt by x means from here x is equal to e to the power t. So here e to the power t dt is equal to t e to the power minus t dt is equal to from here t e to the power minus t dt minus derivative of t is 1 and integration of e to the power minus t is minus e to the power minus t dt is equal to minus t e to the power minus t minus minus plus and integration of e to the power minus t is minus, so minus e to the power minus t is equal to minus t means log x e to the power minus t means x inverse so by x minus e to the power minus t means 1 by x here 2 to infinity, that is here it take 2 to p limit p tends to infinity is equal to limit p tends to infinity minus log p by p minus 1 by p minus log 2 by 2 minus 1 by 2 log p by p tends to infinity, it is infinity by infinity form, so derivative of log p 1 by p and derivative of p is 1, so 1 by p limit p tends to infinity, that means 0 minus limit p tends to infinity 1 by p means 0, so this part is 0, so 0 and if we common negative sign then we get log 2 plus 1 by 2, it is a finite value, so integration 2 to infinity f of x dx is convergent and therefore by integral test the series summation log n by n square is convergent. So option B is true. For option D, it is similar to option B because n equal to 1 to infinity 1 minus cos of 1 by root n into log n. Here a n equal to 1 minus cos of 1 by root n into log n is equal to the same formula 1 minus cos of 2 into 1 by 2 root n, so we get 2 sin square 1 by 2 root n into log n. So this is similar to 2 into 1 by 4n into log n is equal to 1 by 2 into log n by n lesser equal to 1 by 2 into log n by n. But by integral test we can show the series. By integral test we can show the series summation log n by n is divergent because the function 2 to infinity log x by x dx, this integral does not have a finite value. Therefore, the series is divergent. And since this series is divergent, by comparison test, summation an is divergent. Therefore, by comparison test, summation an is equal to summation 1 minus cos of 1 by root n into log n is divergent. Therefore, option D is false. So option D is false. Therefore, here only option A and option B are true. Thank you.